Good day to my friends and our lecturer, Miss Nitya, daughter of Perisami. Today, our group going to present about the applications of differentiation. Before that, we would like to introduce ourselves. My name is Kishan Rai, son of Fatumalai. My metric number is 01DEM20F1004.
Hi, my name is Anand Sharvin, K. Sachinandan Munyandi, and my metric number is 01DEM20F1028.
And I'm Divagar Subramania, and my metric number is 01DEM20F1014.
Hello there, I'm Ganathiban Matruvire and my matrix number is 01DM20F1029 and we are from DEM 2A.
Okay, let me start with my question. Bye guys.
Bye.
Bye.
The first question. Find the stationary point of given function and determine their nature, also known as the maximum point or minimum point or point of inflection of given equation. Hence, sketch the graph. Okay, the equation given for this question is y equals to x cubed minus 6x squared plus 9x plus 5. First, we should differentiate this equation. So the first step is differentiate this equation. So after differentiate, we will get 3x squared minus 12x plus 9. This is the first step. The second step is we need to find the root of the x. So the second step is dy dx equals to 0. The dy dx is the equation we get from the first step. So 3x squared minus 12x plus 9 equals to 0. By using the factorization method, we will get x equals to 3 and x equals to 1. For the next part, I'm going to explain.
Hey, Kishan.
Yes, Ananda?
Let me continue the next steps.
Okay, so my friend going to explain about the next part.
Just let me continue. So, don't bother about him, guys. We will move on. The next step, which is step 3. We are going to find the values of y. How we are going to do that? We are going to find it by doing the substitution method. So, our friend Kishan has found the values of x, which is x equals to 3 and x equals to 1. We are going to use both x value to find the value of y. First, we need to substitute x equals 3 in the equation y equals x cubed minus 6x squared plus 9x plus 5. When we substitute the x into the equation, we will get the value of y equals to 5. Next, we're going to do substitute x equals 1 in y equals the same equation. So when we substitute the x equals 1 into the equation, we will get the value of y equals 9. Hence, we have found the stationary points, which are x3, y5 and x1, y9. The next step is step 4. Step 4, we are going to use the second degree differentiation to find the nature of the equation. So, using the dy dx equals to 3x squared minus 12x plus 9 that our friend Kishan found, we are going to second degree differentiate it to use that to find the nature. So, d square y over dx square is equals to 6x minus 12. Now, with the 6x minus 12, we are going to substitute the value of x, 3 and x1 to find the nature. When x equals to 3 and when we substitute into the the second degree differentiation, we will get the answer 6. Since 6 is more than 0, we know that this point is a minimum point. So minimum point gives us a smile face graph. When x equals to 1 and we substitute it into 6x minus 12, we will get the answer negative 6. Since negative 6 is less than 0, this point is a maximum point, and maximum point gives a sad face graph. So the next step is just the sketching of the graph. But this time, I'm going to call back our friend Kishan Raj to do the sketching of the graph. Again?
Yeah, I'm here, Ananda. I'm here. Okay. Let me continue with the next part.
There you are. Alright, Kishan, you can move on to the next step of sketching the graph.
Okay, the last step is the step 5. In this step, we should able to sketch a graph with the values we found in the previous step. So, as our friend Ananda Shelvin has found the values of stationary point, which is 1x and 9y is the maximum point, and the 3x and 5y is the minimum point of this graph. So maximum point is also known as the sad face graph, and the minimum point also known as the smile face graph. So using that information, we able to sketch the graph. So the graph look like this. So the 1, 9 is the maximum point graph, and the 5, 3 is the minimum point graph. So it looks like this for this question. Hope you all understand the first question about the application of differentiation in finding the stationary point and sketching the graph. We move on to the next part.
Hey guys, I'm Divakar and I'm here to explain to you about rate of change using differentiation. So without wasting your time, let's get into the question. A block of ice in the form of a cube with sides x melts at the rate of 6.2 cm³ per second. Find the rate of change of x at the instant when x is equal to 3 cm. So guys, first of all, we have to gather the information from the question. So the first information is dV over dt, which is the rate of change of volume, is equals to negative 6.23 cm³ per second. So why it is negative 6.23? Because once the ice melts, the size of the ice will decrease. So once it decreases, it will become smaller and smaller. So that's why we're using negative, because it's reducing. That's why we're using negative for dV over dt. And the value of x is equals to 3 cm. And they're asking us to find dx over dt. Okay, from here we can create our own equation, which is dx over dt is equals to dx over dv times with dv over dt. So here guys, we can see one unknown value, which is dx over dv. So how are we going to find that? Okay, this is how we're going to find this. So volume of a cube is equals to x to the power of 3. So once we differentiate that, we will get dv over dx is equals to 3x square. But the unknown is dx over dv. So how are we going to get that? It's really very easy. We just have to inverse the dv over dx. So once we inverse that, we will get dx over dv, the unknown, is equals to 1 over 3x square. So this is how guys we will get the dx over dv. So now we got all the values. Now we just have to apply these values in the formula that we have made.
Yo, Tiwaga, come on, man. Give me a chance, man, to do the next part. Please.
Yeah, Gana, take it. It's all yours now.
Thank you, Tiwaga. So, for the next part, to find the value of dx over dt, we're going to use the equation which our friend Tiwaga showed in previous part, which is this. Boom. Next, we are going to insert the values of dx over dv and dv over dt, which our friend Tiwaga found, which is this. We have known x is equals to 3, so we have to substitute the x in this equation. After substituting the x, we will get 1 over 27 times negative 6.23. Now, we are going to solve 1 over 27 times negative 6.23 and we will get negative 6.23 over 27. So, the final answer we get for dx over dt is negative 0.231 cm per second. This is the solution to find the rate of change of x.
As a conclusion, we have learned two types of application of differentiation. The first one is finding the stationary point of an equation, its nature, and sketching the graph for the equation.
Next, the second application of differentiation that we learn is to finding the rate of change.
Hope everyone watching this able to understand the application of differentiation.
Do like and subscribe.
And don't forget to share.
Goodbye.